Hi everyone. I hope all of you preparing well for upcoming chemistry competitive examinations. So here we are going to analyze a standard model problem which was taken from Pericyclic Reactions Part 1 exam which was conducted on online test series of chemmasters.online. If you are interested, you can visit and join on chemmasters.online and practice high standard online test series, topic wise online test series with mock tests to boost your success rate. And now just look at the given problem. The correct order of solvolysis of the following compounds. So to give answer for this problem, at first we need to look at a generalized reaction of cyclopropyl halide. Okay, so we can thought that in a first step, loss of halide takes place to produce cyclopropyl cation, and further to relieve the ring strain, sigma bond cleave to produce allyl cation. Okay, right, and we can represent all the two resonance structures of allyl cation like this. Okay, right. But experimentally it is observed that the formation of allyl cation from cyclopropyl halide takes place in a single step through concerted process. Okay, so here electrocyclic ring opening takes place in a single step. Okay, right. Now we can say that here 4N system is involving in the ring opening of cyclopropyl halide to produce allylic cation. For that, this rotation is allowed one. Okay, now what is this rotation? Here we can represent opposite movement of orbitals in bond making or bond breaking, simply considered as disrotation. Okay, here the rate of or the order of solvolysis of the given following species or compounds depend on the sense of disrotation. Okay, so here the sense of disrotation decides the rate of solvolysis of the given compounds. Okay, now just try to take allyl cyclopropyl halide, right, and just draw the sigma bond here with lobes. So same side or same kind of lobes interaction produces sigma bond. Okay, I just shaded these two lobes of the two carbon orbitals. Okay, right, now here we have the bond between carbon and halogen, right? So just draw shape the lobe or bottom end lobe. If we do that, now on this rotation, just apply the first kind of this rotation. So back side ring opening, okay, and here is a cleavage of Cl minus takes place here. Both these steps are happening in a single step. That's why we are considering it as concerted process. If you do that, here you can see the shaded lobes will move back side or simply say bottom end. Okay, and the central carbon is having, so here shaded lobe to the bottom end and empty lobe onto the above the plane of it, just say that. Okay, in this case, so whenever the chlorine is cleaving, here the empty lobe interacts with this empty lobe of the carbon, and here is a formation of new bond. Okay, and here you can see, so due to the bond breakage here, the positive charge is absorbed. Okay, now here it is simply equals to allyl cation. Okay, so this is one kind of this rotation where, so you can see opposite orbit bond breaking, right? Now you can take another possible one, another this rotation here, where just make a sigma bond here and shaded loop to be taken above the plane. Okay, and in this case you can see inside, right, just inside this rotation or inside this rotatory ring opening if takes place, then here the shaded lobe moves bottom end, and here for this shaded lobe move above the plane, and here the same, there will be no change on the central carbon orbitals. Here there is a form, there is a new bond between, so same shaded lobes. Okay, and here you can see carbocation, and here where the carbon Cl is or the halogen is cleaved from it. Okay, now just look at the first disrotatory type, in which you can observe that the leaving group just say L and incoming group just say X. Okay, so leaving group and incoming groups are just moving into the same side. Just look at the arrows. Okay, so here you can find this. Okay, right. So we can consider it is a perfect SN2 type of ring opening. Whereas for the second type of disrotatory, that is inside disrotation, you can see inside disrotation, in which, so try to check the leaving group and incoming group, where leaving group is like this, whereas incoming group like this. Okay, you can see incoming group orbital rotation is like this. So it is not like SN2 process. Okay, so the first type of disrotation is the favored disrotation. Here, to open the strained cyclopropane ring in a concerted process. Okay, now which kind of or which sense of disrotation is favored here for the solvolysis of the given compounds? The first one. Okay, now we need to apply this kind of disrotation on the given all the given cyclopropane compounds. Okay, right. Now just try to apply on one or two to give the correct order. And now here I'm just taking this where pH or backside, here hydrogen, here is the hydrogen, okay, and so here is the chlorine, right, in which, as we said, we need to consider this kind of disrotation only which is allowed here, right, and just do this. So here you can get, when you do that, these two phenyl groups move onto the plane, okay, and here you can get allyl cation. So where in a compound or in a reactant where two phenyl groups are same side and the high steric strain can be seen. That's why through this allowed this rotation, it is going to produce a stable allyl cation where the bulk phenyl groups move away from each other. So, highest rate of solvolysis is observed for this compound to relieve strain from that bulk or big phenyl groups which are same side. Okay, so here we can say T is having highest order of solvolysis in the given compounds of cyclopropyl halides, substituted cyclopropyl halides. Okay, and just do the same thing on all other. Okay, and you can get, so by just observing this, you can say option 3 is the correct answer, and apply on all the given compounds. And whenever substrates are increased on the cyclopropyl group, so ring, that means strain increases, ready to produce its allyl cation. Okay, but when you observe these tri-substituted cyclopropane rings, here we need to follow this kind of disrotation, and from that you can say that the solvolysis or the rate of solvolysis is highest for the compound T. Okay, right. Thank you very much.